Let's take a further look at derivatives and their tangent lines. Now, most people, when they're approaching these tangent lines, we're getting a lot of frustration. You have two kinds of problems. One is where you're trying to find the points, and the other where you're trying to find the equation. And so sometimes when they ask you the second one, they give you a point, or sometimes they just give you the x value. Let's look at some samples of both of those. First one, we want to have the points at which a function has a certain slope. And so when you look at this guy, they have to give you the function, and they have to give you the slope. Once you have those two, you're trying to look for the points at which the function has a certain slope. That means when the derivative is a certain slope. So you have to find the derivative, and then you're going to set it equal to that slope that they gave you. So they're going to set it equal to this guy. So you're going to take the function, take the derivative, then you're going to take that derivative and set it equal to that slope. When you do that, you get an equation that you're going to solve, and when you're done, you'll have x values. Now, it could be that you get a solution that says like 0 equals 4 or something where there is no solution, so that means there are no points at which it has a certain slope. But once you do find x values, then you have to go find y values because they're asking you for the points. So here's an example of that. Find all values of x, if any exist, where the tangent line to the graph of, here's this function, is horizontal. Well, horizontal means we want that first derivative to be equal to 0 because horizontal lines have a slope of 0. So let's go ahead and find that first derivative. It's 3x squared, power rule, minus 12, derivative of 2 is 0. Set it equal to 0. And we're setting it equal to 0 because of here. So we're going to set it equal to 0. Go ahead and factor that 3 out. Well, that is the difference of two squares, x plus 2x minus 2. So that gives us, by the 0 property, you set each factor equal to 0. This guy, 3 equals 0, is never true. This one, x plus 2 equals 0, gives you x equals negative 2. And this one, x minus 2 equals 0, gives you x equals 2. So you have two x values. But they're asking you for the values, well, they do say the values of x. So here, the values of x, whoa, scribbling, the values of x, but it's not asking you for points. So that means we're actually done. And that's the solution. There are horizontal tangent lines here. Let's look at the cohort or group of problems. And for this one, they're asking you to find the equation. That means you're going to have y equals something x plus something for the tangent line at a certain point. Sometimes they give you a point, sometimes just the x value. So they have to give you the function. You're going to take that function and find the derivative. Once you do that, you're going to evaluate that derivative at the x value they gave you. And if they gave you a point, it's an x value as well. And so for either one of those, that's going to give you then the slope of the tangent line. Now remember, in order to do y equals mx plus b, we need to have the slope and y-intercept, so we've got to find that y-intercept. So let's go ahead and walk through that. Find the equation of the tangent line to the graph of this thing at this particular point. So here's an x and y. Let's go ahead and use the product rule just for practice. So this is p, so that means p prime is 4x. This is q, so that means q prime is 4. And we know that we want to find that derivative, so it's p prime times q plus p times q prime. We need to have the derivative evaluated at this x value, so x is 2. And we do it at 2 because we want to know the slope of the line there. So f prime of 2, sorry, I wrote the 2 and the x in the wrong place. F prime of 2 is 4 times, we're going to put a 2 in there. So it's 4 times 2, and then here 4 times 2 is 8 plus 6 is 14. And then here 2 squared is 4 times 2 is 8, we'll just put an 8 here. So that gives us, I'm just doing the arithmetic, 8 times 14 plus 5 times 4, and when you multiply those out, you get 132. That is the slope at x equals 2, because that's the derivative evaluated at x equals 2. So we know when we evaluate a derivative at an x value, that's the slope of the tangent line there. Now what we need next is we got to go find that b, because we want to have an equation. And so we've got m equals 132, b equals, I don't know. So let's go ahead and take y equals mx plus b, and we've got slope, and we also have a point, and the point is 270. So 70 equals 132 times 2 plus b. So that's 264. Let's subtract 264 from both sides, and you get b is negative 194. Well, you now have enough information to actually write the equation of the tangent line. Slope plus the b, and that is the tangent line at 270. How did we find that? We found the slope by getting the derivative, and the derivative is the slope of the tangent line, and when you do it at a particular x value, it gets the slope of the tangent line at that value. So that's that 132. We had to find the b, the y-intercept. How do you do that? You use the slope of your line and that point. Let's do one more, and this one's a little more complicated because it's a quotient rule, but that's okay, because we can still take a derivative from that particular function. P is equal to 2x minus 1, so p prime is 2. Q is x plus 2, so q prime is equal to 1, because remember there's a 1 sitting out front here. Then we can go ahead and find that derivative. F prime of x is equal to p prime times q minus p times q prime all over q squared. So that's the quotient rule. Let's go ahead and evaluate that quotient rule where the x value is that they want us to work with, which is here, negative 1. So we're going to substitute it in here, here, and here. So let's do that. F prime of negative 1. Now pause for a second. What's that going to give us? We're evaluating the derivative at a particular x value. Well, the derivative is the slope of the tangent line, so we are finding the slope of the tangent line at negative 1. Get an equation, we need slope and b, so y-intercept, so we're going to do this guy first. So f of negative 1, so what do we get? 2 minus 1 plus 2 is 1. Now I'm in here. 2 times negative 1 is negative 2, times negative 2 minus 1 is negative 3, times that negative out front, so it's negative 3 here. That's going to give us 2 plus 3. In the denominator, we put a negative 1 plus 2 is 1, so 1 squared, 1. So we get, 5. So that's nice. So that tells us slope of the tangent line at x equals negative 1 is 5. So that's what that's giving us. But we didn't just want that, we want the whole equation. So we are going to use that information. So we're going to use the slope is 5, and we're going to use the point, negative 1, oh no, they didn't give me a y value. So I got to go find that y value, and you find that by putting negative 1 in the original function. When you do that, you end up getting -3. I'm not going to walk through that because you can do that. And so we're going to use y equals mx plus b, slope-intercept. Substitute the y in. The slope is 5. Substitute the x in. Go find the b. Well, 5 times -1 is -5, so let's add 5 to both sides. That gives us 2 is b. Now, aren't we done at this point? And the answer is yes. Y equals the slope times x plus the y-intercept. So that's the equation of that line, and let's go ahead and just write real quickly what that is. That's the tangent line at x equals -1. So I would like to encourage you to not get too wrapped up in, oh my gosh, I can't do tangent lines, I'm not sure what to do with tangent lines. They're either going to ask you for the points at which a tangent line has a particular value, or they're going to ask you for an equation at which the tangent line has a certain slope. There are particular ways that you go through both of those. We just went over both of those. So just keep practicing, folks. Don't get overwhelmed with it. Practice it till you own it. So you got to own it to get it in that nugget or kernel of things that you do know. And we're growing that kernel of things you do know and getting them out of that miasma of the gray swirling cloud. And so practice these. You can use any equations, any slope, tangent line, and I think you'll be good to go. I hope you're having a great day.